Okay, and so for this video, we're going to be doing a mole to mass calculation. So that's going to be mole to mass. Okay, so these are, again, pretty simple, but these are two-step equations. Okay, so that means you're going to have to do conversion very similar to what we did earlier, but you're going to add an extra step for molar mass. So some things we need to know beforehand. We're going to say that we're starting off with 2.2 moles of iron sulfide, FeS. Okay, so that's in that equation up here. And we need to convert it. I'd like to know how many mole or how many grams of O2 can react. Okay, so we need to know the grams of O2. So again, we label this A, we label this one B, and so from here, we then set up our generic. So this is what the generic for this looks like. This is going to be moles of A, okay, multiplied by our mole ratio from the equation up here. So in this case, we're looking at the iron sulfide and the oxygen. So at this section, what we need to do is use the ratio from here. So that's going to be moles of B on the top, and that's going to be moles of A on the bottom. Okay, that's the ratio. And then the next step we need to figure and keep into account here is going to be our mass, okay, of B, our molar mass, which is always going to be for 1 mole of B. This way we can cancel things out and know where everything's going to go. So here at this point, that's going to then give us our answer in the mass of B. Okay, so let's use the numbers given here. So I'm going to scoot that up a bit. And so we're given 2.2 moles of iron sulfide. Okay, so using that, we need to then set up the mole ratio. So this would be moles of B on top of moles of A. So if we're looking at this, that would be our moles of oxygen, because oxygen is B, so that's going to be 7 moles of O2. That's what's in the chemical formula up here. Now, we then need to change that and get rid of the moles of FeS, so we'd use this over here. So that's 4 moles of FeS. Okay. Now, what that does is it allows us to use these cross units to cancel moles of FeS. So we know that's gone. So whatever you multiply here and figure out, that is actually going to be technically your moles of O2. Okay? So if we did that calculation, right, we took 2.2 and you multiplied that by 7 and then divided it by 4. I ended up getting roughly around 3.85. So kind of put that off to the side here. And that's if you want to do that in 2 steps. You don't have to. I like to do it all in one big equation because it's clean, neat, and organized. Okay? So when you're doing that, all you have to do now is find the molar mass of B. So we're looking at B as oxygen. So using the periodic table, I looked that up a minute ago, and oxygen's mass on the periodic table is 15.99. Okay, so but it is O2, so we have to multiply that by 2, and that's going to give me a total of 31.98 grams per mole. Okay, and again, this was gotten, this number right here, from the periodic table. Atomic mass. Okay, so from there, now we have the molar mass. That's 31.98 grams of oxygen per every 1 mole. We would just move that over here and write it out as a full ratio. So 31.98 grams of O2 is equal to 1 mole of O2. And then when you multiply that out, right, now look what cancels. The moles here and the moles there are dividing each other, so they're gone. So now you take 2.2 times 7, divide by 4. So you always multiply by the tops, divide by the bottoms. And then the number you get there, which again was about 3.85 for me earlier, and you multiply that by 31.98. And the only unit that's left that I haven't crossed out is grams of O2. So we know that's going to be grams of oxygen. Now, if you want to pause it, enter it into your calculator and see what you get. Okay. The answer I got is 123.123. Okay, and that is my answer. That is my mass of oxygen that can react with those 2.2 moles of iron sulfide. Okay, so that's a mole to mass problem.